This presentation is about how everyday business challenges can be addressed through the lens of data science, and for this particular study, with machine learning. Now, I know what you're thinking. Data science can sound so mysterious, and machine learning is moving at a dizzying pace. Most businesses recognize that they need these capabilities, but find themselves stuck between relying on expensive, prepackaged AI solutions and watching competitors pull ahead. The gap between recognizing the potential and actually implementing data science in day-to-day operations feel overwhelming. You're concerned about the investment, the expertise required, and most importantly, how to execute data science approaches for your specific business challenges. But imagine this, you're an owner of an unknown object at the Antiques Roadshow. The object? Your data. Just how much is your data really worth? In today's data-driven world, businesses are sitting on a goldmine of information. For this study, we're looking at a leading used car dealership. They've started collecting data on vintage cars with a goal of more efficiently targeting their audience. Before diving in further, my name is Michael Chang, strategic leader in data-driven decision-making. I specialize in optimizing operations and fostering collaboration. My diverse background is a blend of formal education in the arts and liberal arts with extensive experience in the tech industry. With more than 3 decades of experience, I have a robust understanding of data collection, interpretation, and data management. Now back to our study. Many believe that the value of vintage cars is purely sentimental, driven by nostalgia. The market is vast and diverse, and each group of vehicles has a slightly different target audience. The common belief is that these valuations are always based on emotion and passion and can't be predicted with data, right? Wrong. Before looking at what data can do in predicting vintage cars, let's think about what makes vintage cars vintage in the first place. We often assume a car becomes vintage simply by hitting a certain age. That's like saying any old chair is an antique, and it misses the whole story. As the used car dealership in this study is shifting focus to vintage cars, it's not just about what's old, it's about what resonates, what's special, and how to target the right buyers. Vintage then isn't just about age, it's about mystique and cultural relevance. Sometimes that rare car from the 70s is more vintage than a car from the 1950s. As a matter of fact, hidden within the study's database is the super rare International Harvester 1200D. It's almost like a ghost in the data. The 1970 International Harvester 1200D is a rare and sought-after vintage pickup truck, prized for its ruggedness, reliability, and nostalgic appeal. So vintage isn't a number, it's a feeling, a story, a connection to the past. But how do we go beyond just age to really defining vintage using data? Well, first we have to clean the data. Even seemingly small inconsistencies in the data, like using VW instead of Volkswagen, can really throw off an analysis. So data governance and operations optimizations help standardize how data is collected and consistently reported. But having clean data is only the first step. You see, many times we encounter qualities that are elusive, hard to pin down, and the je ne sais quoi intangible elements that defy easy explanations. When confronted with this, it's easy to simply try and reach for more data, but that would have been a costly mistake in this study. Hypothesis testing compared data clusters between using all available features for the vehicles to only the core features, model and year. Turns out, using only model and year for this dataset dramatically improved machine learning results. So rather than only relying on intuition, the data helps us confidently evaluate relationships along 3 dimensions: silhouette score, coefficient of variation, and relative range. The silhouette score objectively measures how well each data fits within the cluster. The coefficient of variation measures consistency with less sensitivity to outliers. The relative range measures consistency as well, but with more sensitivity to outliers. The result? By only using model and year rather than the full features of the vehicles, the silhouette score improved more than 90%, and variation was reduced by more than 92% with coefficient of variation and more than 90% with relative range. So far, we've classified vintage cars using data. But what if we could predict which cars will be considered vintage in the future? You see, not only is data management about governance and a strategic approach to data integrity, but it's also the foundation to leveraging our data for decision making and predictive analysis. The big question remains, how do we go beyond just analyzing the cars of yesterday to predicting the vintage cars of the future? Here's where supervised learning comes into play. Think of it as teaching a computer to see what the expert sees. To do this, we need labeled data. This means a domain expert reviews our data and identifies which cars are truly vintage. Remember, vintage isn't just about age, it's about mystique and cultural relevance. A human touch is needed. They'll label each car as vintage or not vintage. This labeled dataset becomes our training data. Now we feed the data into a supervised learning model. Algorithms like decision trees and random forests can learn the relationships between a car's features and its vintage classification. Of course, we need to evaluate how well our model is doing. We use metrics like accuracy, precision, and recall to measure its performance. If the model isn't accurate enough, we can refine it by adding more data, adjusting the algorithm, or engineering new features. So, how does this help out our used car dealership? With a predictive model, they can identify potential vintage cars quickly and efficiently, target marketing efforts to the right buyers, increasing sales, gain a deeper understanding of what makes a car truly vintage, and optimize inventory and pricing strategies. This journey through vintage cars illustrates something fundamental about everyday data science. You don't need an extensive machine learning team or massive investments to get started to see real value. Basic clustering techniques revealed patterns that intuition alone couldn't capture. Collaboration between business domain experts and data analysis created the breakthrough. So, how much is your data really worth? With the right approach, one that's accessible to organizations of any size, the answer is far more than you might think. The true measure isn't in the complexity of your algorithms, but in how effectively you transform data into better business decisions. To see this in action, click on the link below to run this analysis yourself. Then, within the notebook, click on the play button to execute each step of the study. Experience firsthand how accessible data science can be with the right approach. Thank you for watching. My name is Michael Chang. My LinkedIn profile is on the screen. I look forward to hearing from you.